Let's determine how much product or how many moles of products we can get from 3 moles of propane. Before doing that, there's one important thing that we want to do here. We want to first understand the meaning of the chemical equation. Any chemical equation has these numbers which are called the coefficient, and these coefficients tell us how many moles of each molecule we have. So here propane is 1 mole and the 1 is not shown, but it's still there. So if we want to read this equation, we want to understand that every 1 mole of propane reacts with 5 moles of oxygen, produces 3 moles of carbon dioxide, and 4 moles of water. Now, how many moles of carbon dioxide and water we'll have from 3 moles of propane? What we can do is we can put 3 moles here on top of the propane, and we can do the calculation based on these ratios. So I have this example here. This is the same representation as if you look at this example with the fruits. So for example, let's say we're producing some jams and fruits. So 1 pineapple mixed with 5 strawberries can produce 3 jams and 4 boxes of the juice. So these numbers in front of the molecules are the amounts of each unit entity that we're using here. So don't be confused with these numbers, with the subscripts here. These don't matter. So all of these together, O2 is one entity, one unit. This is a 1 unit. This is a 1 unit. And same here. This C3H8 together is 1 unit. So we don't really worry about these numbers here. These are just used to balance the chemical equation and obviously to have the correct formula of the compounds. So now let's think about this. If we have 3 pineapples, how many jams we can prepare? So every 1 pineapple produces 3 jams. So if we have 3, this is going to be 3 times more. So 3 times 3, which means that 9 moles of carbon dioxide. Same if we're talking about the water, we're going to multiply 4 times 3 and we have 12 moles of water. And for the oxygen, 5 times 3, we're going to have 15 moles of oxygen. So this is how quickly you can determine how many moles of each product will be formed or how many moles of the reactant is necessary to react with the first reactant. Now sometimes the situation may not be as easy because you may not have necessarily the amount of the product that has 1 in front of it. What if, for example, we have a situation where we are asked to find number of the moles based on the oxygen? Yes, so for example, let me get some space. So if we have just any number, let's say we have 6 moles of oxygen and we're asked to determine how many moles of CO2 and water will be formed. This time there's no 1 in front of the oxygen, so we cannot simply multiply 3 times 6. But what you can do is you can say that, well, okay, so let's say I get X moles of CO2 and I want to find what is the X. And so here you can just simply use the cross multiplication. What you can say is that every 5 moles of oxygen, based on the equation again, so every 5 strawberries give me 3 jams. So every 5 moles of the oxygen give me 3 moles of CO2. So I'm going to write every 5 gives me 3 moles of CO2. And then I'll write down what about if I have 6 moles. So every 6 moles of oxygen will give me X moles of CO2. So if I want to find the X, I'm just going to multiply these 2 numbers, 3 times 6 divided by 5. Which is what you do exactly here. Without even setting this up, you can just do it here. You can do 3 times 6 cross multiplication and then divided by 5. So I can just multiply these numbers. So 3 times 6 divided by 5, and what we have is 3.6 moles of CO2. Let's now quickly do for the water. Let's say this is X moles. I don't know how many moles it is. What I do is I take this number that is in front of it, multiply with this number, 4 times 6, so this is equal 4 times 6, and I divide by 5. So 24 divided by 5, 4.8 moles of water will be formed here. We can write down 4.8 moles. And we can do it for any mole ratio. You can just put X here and cross multiply. At some point, if you practice, it will be just easy. You just put the number here without even crossing this. You immediately find it. And if the amount of the reactants are given, for example, in grams, let's say you have a problem that you have in the number of the the amount of the propane in grams. Let's say you have 5 grams of propane. What you want to do is you want to convert these to moles, and then you can find the moles of CO2 and the H2O based on the mole ratio. So here we're going to use the mole ratio. In the stoichiometry, the key is here. You want to convert everything that is given, whether it's in grams or volume, to mole ratio, and then we can do the conversions here. In the next few problems, we'll do some examples converting from the grams, so you can get more practice on this.